Pallavi. Today I'm excited to share my understanding on a research paper on zero shot bilingual app reviews mining with large language models. It is a novel approach to understand the user feedback in both English and French without the use of extensive training data. So let's dive deep into it. This research aims to help app developers efficiently analyze user reviews in both English and French in order to improve their products. Reviews contain valuable feedback, but it is often burdensome and hard to review them manually. The authors propose an automated tool called Minibar that can classify, cluster, summarize, and rank app reviews without needing any manual labeling of data. This is achieved through a novel approach leveraging large language models such as ChatGPT in a zero shot manner, thus eliminating the dependency on labeled data. App stores give users an ability to post reviews about their experiences with apps. These reviews often describe software defects users have noticed or request for more new features to be added, providing crucial feedback for developers looking to maintain their products. However, the reviews number in thousands for most moderately successful apps. Manually reviewing user sentiment at such large volume is just not feasible. Though there has been some research into applying natural language processing techniques to help automate the analysis, most of the existing techniques need manually labeled data to train machine learning models for understanding review text. Acquiring substantially labeled corpuses is expensive. So, let's see what is the objective of this research. The authors of this paper hence set out to investigate techniques which can analyze both English and French user reviews without requiring any labeled training data whatsoever. Their tool, Minibar, provides capabilities for classifying user reviews into feature requests, bug reports, and irrelevant, clustering similar issues and requests submitted by users, generating summaries of the clusters, and prioritizing which clusters should be tackled first by the development teams based on severity. They created a dataset of 12,000 app reviews, evenly split into English and French, from three fitness apps which were manually annotated to establish ground truth for evaluation. The authors benchmarked the zero shot classification accuracy using ChatGPT against traditional machine learning methods like random forests and SVMs, as well as the state of the art natural language processing algorithms, including BERT, XLM, Robot A, and MC4. They curated a labeled dataset of 12,000 app reviews, evenly divided over English or French, and three uh, app categories. The data set was split 80 by 20 for training and testing, five baseline models, while ChatGPT inferencing was run directly on the test set. All models were tasked with categorizing each review as either a feature request, bug report, or irrelevant review. Across the averaged metrics over three app corpuses and both languages, ChatGPT achieved a 85% F1 score, which came quite close to the best performing XLM robot model, showing the power of zero shot learning. An interesting observation made is that while ChatGPT lagged for feature requests, it actually exceeded established benchmarks on defect classification, hitting 97% recall. This can be attributed to the conversational nature of such queries suiting the strengths of this LLM architecture. Critically, zero shot ChatGPT eliminated the need for any training data or model reconfiguration when extending the same classification capability to French language reviews as well, which existing solutions would struggle with. The consistent score aligns with notion that LLMs exhibit surprisingly multilingual support despite not being explicitly trained for them. So, clustering, the authors leveraged neural net text embeddings specifically generated from review text to group related pieces of feedback using density based hierarchical clustering. Text embeddings convert sequences of words into abstract numerical representations capturing underlying semantics. They extract embeddings for all reviews, including the instructor model, which provides generic encoders tailored to tasks through simple instructions. Dimensions were reduced from 768 to 20 using UMAP before applying HDB scan clustering. The clusters were generated independently for English reviews and French reviews belonging to same category. Performance was measured using normalized mutual information, or in short NMI, between model clusters and those created manually by annotators. An NMI score close to 1 indicates greater agreement. The overall NMI achieved on the bilingual dataset was zero point 0.6 plus, indicating reasonably meaningful clusters according to the underlying topics within the reviews. Review length didn't show clear correlation. As expected from prior research, embeddings trained on much larger English datasets outperformed French counterparts by 9% NMI owing to the transfer learning. So, to summarize, for each cluster, an abstractive one sentence summary is generated using ChatGPT, again in a zero shot manner. Quantitative evaluation by having humans rate on criteria like relevance, consistency, and coherence should that the summaries provide excellent encapsulation of the key user feedback within a cluster. The ChatGPT performance exceeded both extractive summarization baselines as well as other large language models. Ranking. Finally, the identified clusters are ranked in a priority order based on the volume of reviews, the average rating, and the number of helpful votes so that app developers can systematically determine which issues need immediate attention. In summary, their comprehensive empirical evaluation indicates that the proposed minibar pipeline enables effective mining of bilingual app reviews without needing any labeled data through the leveraging of capabilities of ChatGPT and other LLMs. Both the classification and clustering stages show strong performance on the manually annotated dataset collected from real world apps. To see the limitations of this model, while the minibar approach shows promise, the authors acknowledge some limitations. Firstly, the app reviews used for evaluation are all belong to health and fitness apps. Additional analysis on other categories such as gaming, financial, or navigation apps could reveal different challenges. Secondly, the scale of labeled data available for some experiments like clustering was restricted to thousands of reviews. Performance of clustering methods tends to improve with larger datasets, which allow the models to learn more effectively. Access to corpora with millions of labeled reviews could potentially boost results. Lastly, usage of certain language models like ChatGPT currently comes with some restrictions around accessibility and pricing. Also, certain users may have privacy concerns regarding transmitting data to external AI services. Integration with such large pre trained models may hence inhibit adoption. So, to conclude the understanding of this paper, the authors are therefore able to demonstrate an automated approach using recent advances in artificial intelligence to unlock the value present within large swatches of user reviews that dynamically improve as more feedback data is aggregated. Their technique can help app developers tap into these rich insights to build better apps. The presented solution can generalize to multilingual scenarios without modifications and does not require complex training data.